will focus on the historic inaugural flight of Ariane 6, which, as you may all know, took place on 9th of July this year. And this remarkable achievement marks a major milestone of European space exploration, with a brand new rocket launching from a new pad. Despite inherent challenges, Ariane 6 succeeded on its first attempt, showcasing European engineering excellence. In these sessions, experts will explore how the space team Europe, including ESA, CNES, Ariane Group, Ariane Space, achieved this success, the challenges they had to overcome, and the innovation that paved the way for Ariane 6 to launch Europe into a new era of space exploration. You will have the opportunity to ask questions to our distinguished speakers using our Slido system, which you are for sure already very familiar with. Please use the hashtag IEC 2024, register, and then please submit your questions. And it is now my distinct pleasure and honor to introduce and to welcome on stage the moderator of this late-breaking news session, Ariane from the European Space Agency. Please give her a warm round of applause. Thank you.
Hello, everybody. Welcome for the late-breaking news this morning. I would like to introduce you the three experts that will talk about this today. As you said, you will have the app. Please ask your questions and we will answer it at the end of the presentations. So I would like to welcome on stage Piero Resta from the European Space Agency, Ariane 6 Program Manager, François Deneux, Ariane 6 Program Manager at launcher level for Ariane Group, and Olivier Bunier, CNES, the Ariane 6 Project Manager for the launch-based structures and means. Sir, the floor is yours.
So finally came the day in which we shall speak about the first mission of Ariane 6. That I said before I had, it has been a great success because it corresponded to the way, to the spirit, and to the methodology that we have applied to the development, that is right first time. Right first time has inspired all the development process since the beginning. We will see some detail about it. And right first time, thank you very much. And it has been, and right first time has been the result of the first flight. So just a short recall of what is the fleet of European launchers. Until mid-2023, we had a heavy lift launcher on the launch pad. It is Ariane 5 that has completed this brilliant career with extraordinary launches like JUICE and especially James Webb Space Telescope. And then it is to be replaced by Ariane 6, especially the heavy configuration of Ariane 6 that is with 4 boosters, what we call the Ariane 64, and the same for the phase out of Soyuz that was accelerated by the famous event in East Europe, and is to be replaced by the light version of Ariane 6 that is called Ariane 62, where 2 is the number of the booster that are integrated in the launcher configuration. The Ariane 6 program was born in 2014, at the ministerial 2014, and it was set up, I shall say, quite quickly, because there was a sudden change of direction with the abandonment of Ariane 5 ME and the switch directly to an Ariane 6 that would have been using the greatest possible heritage from Ariane 5, so without major changes in the lower stage propulsion architecture, but with a lot of changes in the industrialization chain, the manufacturing chain, and with the innovation of reusable, reignitable, upper stage based on the motor Vinci. the Ariane 6 program could be implemented thanks to the cooperation of many countries of Europe, which too early, back. Many countries of Europe that have participated and participate to the development of Ariane 6 and will be the consortium that will produce the launcher under the mastering of our launcher system Prime Ariane Group. And here is the day. Here it is the day. You can recognize some faces that are here in the room today. Someone is not there, like Karim, that is represented, the director of CNES Space Transportation, represented here by Olivier Bougnier. What were the role of ESA? The role of ESA was threefold, basically. The program management, so the classical role of ESA in the relationship with the participating states and delegation, the procuring entity individually of the launcher system and the ground segment, what we call the launch base, and the launch system architect, that is the function that I have had the honor to lead. The launch system architect was integrating the two segments, ground and flight, performing the system verification and checking the compliance to the high-level requirements of Ariane 6.
Yes. CNES, you will see on this slide that CNES has had several tasks and several responsibilities in the development of Ariane 6. One of them is the classical, I would say, French Guiana Spaceport and Launch Range Authority, but also the Safety and Space Law Compliance Authority. This responsibility on space law and safety is independent from the developments and from the program. And so my task as Ariane 6 program manager in CNES was to bring a consistent behavior, consistent view and actions on CNES on their several tasks. So this was the first responsibility.
And the Ariane Group, we are the prime contractor for the launcher system. For the launcher system, as you know it, this is not only the launcher, this is also the complete production system, including the industrialization of the complete chain. And of course, this is not only Ariane Group who delivers the launcher. And by the way, at the inaugural flight, we have delivered the launcher at 0 to ESA, because ESA was also the launch operator. But this is with our partners that we deliver the launcher, and the launcher system, the production system is also within the factories of our partners. So we have 15 major partners, and we have more than 300 suppliers on this program all over Europe, since we have 13 countries involved in the program as presented by Piero.
So CNES developed the ground segment, the ELA4 that we see behind this picture, and we will see several pictures later on. And the adaptation of the launch range, the CSG, the Guiana Space Center, was adapted for Soyuz, Vega, and Ariane 5, and needed some adaptation to be adapted to Ariane 6. So this new launch pad was built from scratch. It was not a refurbishment of an old one, and worked perfectly well in July.
And so for also the inaugural flight, so we were the operations conductor, integrated with CNES in a joint team. And it was just after the combined test, and I can say, Olivier, that during the combined test, it was the reverse. CNES was the conductor, Ariane Group was the deputy, And so we organize this so that we have a very mature system at the day of the inaugural flight. And CNES was developed the launch complex has made possible to Ariane Group to operate the launcher for the first flight and after for the exploitation.
Yes, and indeed it is in 4 steps that Ariane Group take the exploitation of the launch pad. So in the first step, CNES developed the launch pad and qualify it alone without a launcher. The second step, which was really important for the first time for the first campaign, was what we call the combined test, which means that with a almost real launcher, it is a real launcher without the real boosters, were tested in the launch pad all the chronology, the nominal and degraded cases. And it was performed under the responsibility of CNES with the integration of Ariane Group teams. And on inaugural flight, as said by François, we switch responsibility of Ariane Group with the support of CNES team. And from the next launch, which is a commercial launch, it will be operated by Ariane Group.
So this is the organization that also corresponds to the principle of the right first time, because, as explained by François and Olivier, the roles of CNES and Ariane Group were set in a way to secure the quickest path to the inaugural flight, but also to secure that the inaugural flight is the first of a series of successful flight in exploitation, with the exchange of role between CNES and Ariane Group, CNES that led the role of the test conductor under ESA responsibility for the combined test, and then progressively shift the role of operation manager to Ariane Group, because they have to implement this role for the exploitation campaigns. So another answer to the question, how did we succeed, is the way we have planned the development and verification process, joined very tightly with the decision process that is led at management level. We introduced some important modification in 2022 that have led to really streamline, and I use this word because indeed the management routine was also called a streamlined management team, and it was based on a set of instance of problem analysis, escalating, and decision that has allowed to take decision as quick as possible. And sometimes the decisions were not that easy, as you can imagine. So we had joined the 3 teams with the design authorities, ESA, as launch system architect in groups called end-to-end engineering team. Then we had a coordination at the level of chief engineers of ESA, Ariane Group, and CNES. And then we had this management team called SMT, where the program management of ESA, Ariane Group, and CNES were sitting, with the participation of Ariane Space that has to take the lead for the exploitation. And at the end of the escalation, we find the task force, the Ariane 6 task force, that is at director level. It was an entity to which we brought all the status, and we received recommendations, and it is composed by Joseph Aschbacher, our ESA Director General, the CEO of Ariane Group, Martin Sion, and the President of CNES, Philippe Baptiste. The development program has been set out so as to eliminate the risk as early as possible. We started with the idea that we would have tested everything with the real launch base and the real launcher already, with the launch base already qualified, and the real launcher in the classical combined test campaign. We decided already in 2017 to introduce preliminary test at system level called early combined test, and already in the development logic, we will listen from François the explanation of the importance of the upper stage firing test performed in Lampoltaso. We designed and built with DLR colleagues a new test bench called the P5.2 in Lampolthausen, and there the complexity and the very important performance of the upper stage were tested in a very deep way. Last, we performed on the launch pad, so the launch pad was for 1 day converted in a test bench. We performed a long firing test of the lower stage of Ariane 6. And indeed, this has led to the fact that the last leg of the development, the last part of the development, was incredibly efficient. We performed all the combined tests we performed all the combined tests in the defined timeline, and the launch on the 9th of July, as announced many weeks before, some months before, it was performed on time. Aside that, the qualification process with the classical ESA approach and the classical Ariane in general approach to the reviews. You see the effect, we visualize the effect of how we performed this qualification review that we call the smart process qualification review. And it was a review that was performed integrated between ESA and Ariane Group on the launch system and launcher system together in 2 big steps, one in April and the other in June 2024. And this was the last element that has played a very important role in the achievement of the inaugural flight.
Maybe we can say just before, maybe for the first time of development, at least in Europe, the qualification of the launcher and the launch base was not on the critical path, meaning that we were successful in anticipating the qualification of all these elements in 2 steps, as said, in July 23 and after in April 24. With a very condensed period of time with all the experts in Europe working with the project team so that we can go fast in qualifying the launcher. And so this is what we have called the conclave. Maybe this was the Roma influence, I don't know, Piero. But at least we are not in Roma here, but we are close to. And so this was quite new, the way we have implemented this way of working together. And it was a launch system and a launcher system jointly in parallel with the launch base. So we were successful in qualifying this very complex system at the same time. And I think that we were very happy to hear from the top management and the people having decades of experience, especially on Ariane 5 at the end of the qualification of the launcher and launch system, telling us the quality that you have achieved is the best we have ever seen on the development. And so, at the same time, we were successful in putting the schedule under control. We have delivered a qualification documentation, which was very good also. And the success of the flight is also the result of this, because it's not enough to have a launcher on the launch pad. You need, before the flight, to demonstrate that everything is under control, that all your models are okay, and that you have tested, and you have demonstrated on the paper that you can fly.
Yes, and I want to use the opportunity in front of you to very warmly thank all the teams, the hundreds of teams that performed these activities with very huge engagement, very huge effort during months to deliver the stages, to perform the test, to deliver the documentation. And it was really a momentum of work, of common work. And so really warmly thanks to the team. Some of you are here, some can hear us outside this room, but really warm thanks to all of you. So no, it was not this one. So a scheme of the operational concept of Ariane 6. Maybe we will not take too much time on this, but some words. So as on Ariane 5, a major part of Ariane 6 is built in mainland Europe. The boosters are filled in Guyana, in the Propergol facilities in Guyana. The one important thing to have in mind is that all these steps that are the nominal steps in Ariane 6 launch campaign has been tested in nominal and degraded cases during the combined test. And so, step by step, we qualified, verified, and validate these different steps until Ariane 6 is built inside the mobile gantry. Mobile gantry, as you see on the picture, has been removed only some hours before the launch, but during the several days before the launch, we work inside the mobile gantry. This is a very huge building, more than 100 meters high, and several thousands of tons of this huge structure that is mobile and leave the floor for the liftoff, the day of the liftoff. Maybe on this slide, it's okay, colleagues. Go. So the launch pad and the launch system element, as I said, there is this huge mobile gantry. On the left side, you have a picture of the cryogenic fueling arms. So heavy arms allowing to fill and empty, if needed, the upper stage with liquid oxygen and liquid hydrogen. Below, you find on the right side, below of this picture, you see the assembly building, the lower stage and upper stage, lower module and upper module are assembled in this horizontally in this building. They are transported to the launch pad. We will see picture right after to the launch pad on some dollies. There are some hundreds meters from this assembly building to the launch pad. And the verticalization is performed on the launch zone. So all this has been developed by CNES and its suppliers and industrialists.
Okay, so the Ariane. You know that the configuration of Ariane has been made so that we have as much as possible flexibility during the exploitation phase. And this is the reason why we have these two versions with 2 boosters or with 4 boosters, so that we can adjust the performance of the launcher, and so, of course, the cost, the price of the launch to the need of the customer, and so that we can also address more easily at the same time the commercial market, but also, of course, the institutional market for the European missions especially. And something which was also invented, I would say, on Ariane 6 is to develop a common booster between Ariane 6 and Vega, the evolution of Vega, the Vega C. And so the booster of one booster of Ariane 6 is also the first stage of Vega. And Ariane Group, we have developed this booster with Avio jointly together, and it has flown 2 times on Vega, and now 2 times on Ariane 6. After the design of the launcher is something that which is quite common because it's using some of the technologies of Ariane 5. So we have the 2 solid rocket booster or 4 solid rocket booster, and the purpose of which is to take off and to provide the thrust at the beginning of the flight. After we have 7 minutes of flight with the main stage, the LLPM, what we call the LLPM, but this is the main stage of Ariane 6. And after we have the upper stage and the upper part. As said before, the main stage and the upper stage, we are using liquid oxygen and liquid hydrogen, so the most powerful propellant that we can use in our domain. And this is, of course, an heritage of Ariane 5. What is new, and very new, is the new engine that we are using on the upper stage, the Vinci. And the capability of Vinci is very different vis-à-vis the HM7 of Ariane 5 because this is a reignitable engine. But you know, this is not enough to have a reignitable engine. You need to develop a reignitable stage, and this is a bit more complex because this is not just at the ignition of the engine that you need to make sure. This is the stage itself that we have to control, and especially all the fluid management for the stage is very important. And at the beginning of a bit after the beginning of the development, we have seen that the market was evolving very rapidly, the constellations were there, the missions to be addressed by Ariane 6 has increased drastically, and we had to make a choice: either we stay with the initial configuration or we change the configuration to adapt to the market. Guess what? We have adapted the launcher to the market. And so this upper stage on Ariane 6 is not an upper stage, this is an upper and orbital stage, meaning that we have the capability to go into orbit, to maneuver, to change the orbital plan, to ignite the engine, to reignite the engine, and for that we have added to the Vinci a secondary propulsion system that we call APU. APU is... The name means auxiliary power unit, so you see that at the beginning it was just to provide some power so that we can reignite the engine. And years after, it becomes a completely propulsion system. So we have on the upper stage, on the orbital stage, 2 propulsion systems using the same propellant, fed from the same tanks. And this is a closed loop because the APU is also used for the pressurization of the tanks. And so this is what makes Ariane 6 beautiful, very performant and very flexible. This is also, from a program manager point of view, how you make your program a bit more complex in the middle of the development. But we were successful, and now we know that we have developed something which is very powerful and very promising for the customers. And we will see at the end that the backlog of Ariane 6 is really well booked, and this is because we can address all these missions thanks to this very innovative upper stage. Okay, so as I said before, this is the typical illustration of what we can do with Ariane 6. Very classical missions, as we did a lot with Ariane 5, especially the GTO with single and dual launch. The heavy LEO missions also, the large science satellites, which was also the capability of Ariane 5. We can recall, for instance, James Webb launched 2 years ago by Ariane 5. But what is a bit new with an illustration of what the capability offered by Ariane 6, this is the capability to launch the Galileo constellation. It was true for Ariane 5, but with a different upper stage. Here we do it with the same upper stage. And as I said before, the capability to launch LEO constellations on different orbit is now capabilities that we offer with Ariane 6. And for those who know quite well the backlog of our missions, this is a very important segment of the commercial market of Ariane 6.
And François, we may just on this slide remind also the extreme care that we had since the beginning of Ariane 6 on the conditions that we offer to the payloads that will be on board, offering a very important volume under the fairing. We have the fairing in two different sizes. Cool. And with respect to Ariane 5, we had the innovation that the payload that is in case of the dual launch, the payload in the upper position, the payload in the lower position, have almost the very same environmental conditions, and we shall not longer distinguish between a primary and a secondary payload. And the fact that we are introducing also new auxiliary payload services through the initiative that is called Multi-Launch Service, MLS, that will be soon on board the launcher, and they will offer some very interesting opportunity for payload of a smaller dimension, 500 kilograms, 1 ton. And last, it is not in the picture, we are also developing for Ariane 6 an orbital transfer vehicle associated with the launcher to perform classical services like last miles, change of some orbital parameters, and this will allow also the definition of new kind of ride share. Ariane 6 is very modern.
Okay. Now we will move to the inaugural flight. But before being able to assemble a launcher in Kourou and to fly, you need to produce the launcher. And something also which was new on Ariane 6 is the development of the production segment, much in advance in the development. We have started to develop the factory in 2017 and 2018. Not only within Ariane Group, but also all over Europe with our partners. And so the launcher that we have tested in Kourou, the launcher that we have tested in Lampol 1000 before the inaugural flight have been manufactured, tested and delivered by the production factory, by the exploitation factories. And so it was a way for us to, well in advance, to progress on the industrialization and to have the possibility from the beginning to engage an important ramp-up for the production, and you will see at the end of the production that this is where we are. So before going to Kourou, we had to manufacture the different elements of integration, to integrate these different elements in our factories in Europe. So mainly in Italy for the booster structure, in Bordeaux for the manufacturing of the booster nozzle and also the skirts of the booster. But also the integration factory in Bremen for the upper and orbital stage, and in Les Mureaux for the integration of the main stage. Of course, we had also factories in Spain for the composite structure, in Germany for the metallic structure, also in the Netherlands for the huge rear part of the launcher, which is manufactured in the Netherlands. and also in Belgium, for instance, for the actuators, or in Switzerland for the fairing. All of these have been developed with adapted or new factories. And of course, we have the same in Kourou for the solid rocket booster, because we don't travel with 140 tons of propellant across the Atlantic. So basically, we transfer the structure and we cast the propellant, and we integrate the stage, the booster in Kourou, in also integrated factories. 2 points I would like to mention, because we talk a lot about hardware, and this is what is visible and what is easy to understand. But preparing a launch, this is not just producing hardware, this is also producing software. And so we have in LeMuro functional simulation and capability to develop and test intensively the software in very different conditions. And what was a bit new also on Ariane 6 is to have in LeMuro a replica of the launch base that we test with the hardware in an Ironbird environment. And in Kourou, CNES, they have the replica of the launcher so that they can test also the launcher in front of the launch base when they develop their software and control bench. And something also I like very much is in such a program we have 10,000 of pieces. We have a lot of major structures and so on, and we have to transfer the launcher across the Atlantic. So the logistics is very, very important, and the transportation of massive and very volumic structure is also important. And so I'm very pleased also to introduce Canopy, which is a ship that we have developed to transport from continental Europe to Kourou, the main elements of the launcher. And you know that this ship is not just a transportation ship. We have developed it so that it's also a revolution in maritime transportation, because it was the first operational ship to use wings. And with these wings, we have the possibility first to reduce by 30% the cost of the propellant, because we use the wind, and the wind is free. And second, we have the possibility to adapt the speed of the transfer from continental Europe to Kourou. And so by doing that, we have the possibility also to accommodate the logistics to the cadence of the launcher and to adapt the cost to this.
And reducing the environmental footprint, by the way.
Yeah. So sorry, because you're right, of course. When you save propellant, fuel and cost, you save also some tons of CO2 for the planet. But initially, this was not our goal, and at the end, we have changed the world of the maritime transportation. We are very proud of it. And so after once you are in Kourou, you have to continue the process of integration. So in our factories for the solid rocket booster, and here you see the different elements, how they are integrated and produced in Kourou. In Kourou, as said before, we have also a building for the assembly. This is a building that looks like very much to what we have in LeMuro. And this is not a surprise, because we have developed this with the same suppliers, same partners. By the way, we have changed drastically the way we integrate the launchers on Ariane 6, because now we integrate this horizontally. And we have used for this the knowledge of the aeronautics and the people, La Técolaire, who have developed this for us. They have also developed the horizontal line of assembly of the Airbus in Toulouse. And so when we say we reduce the cost of Ariane 6, this is not pure magic. And this is because we have changed our way of working, and this is because we have used the methods and the capability of the aeronautics to cut down the cost of integrating the launcher in our domain. So this was the integration in the factory in Kourou. And after, we have to move to the launch pad under the mobile gantry, as described by Olivier. So here, this is very spectacular because this is the moment we have to move from the horizontal position for the central core to the vertical one. Of course, we need to be vertical to take off. And so this was a very great moment, end of April, to see the launcher leaving the factories to integrate the launch pad. And in less than 4 days, we were capable to transfer the booster, to transfer the central core, to assemble it under the mobile gantry. We did that previously during the combined test, as explained by Olivier and Pierrot. I mean, of course, on the program, this was identified as a major risk. How we will do that, because this is the first time, this is totally different vis-à-vis Ariane 5, and in fact, it was probably what we did, and with a very strict respect of the schedule, very well prepared, no anomaly. It was like in a dream. It was, of course, very well anticipated. So I say that because sometimes you have in your risk register big topics and you don't know what will happen later on. But when you address these big topics properly, at the end, this is no more a risk. And so between end of April and beginning of May, we move from everything is in the factory to the launcher is on the launch pad, it is connected, and we can start the functional test under the mobile gantry.
And I would understand the comment of Olivier also on the overall cycle of integration and preparation to launch of the launcher on the launch pad, because we have made very important choices that make the launch complex of Ariane 6 extremely environmental friendly with respect to the previous launch pad that are in Kourou, thanks to choices that reduce at the minimum the use of energy. We have made the brave choice not to put climatization in the mobile gantry at the condition that we stay in the mobile gantry for a very few days. The target is 3 days. Of course, this was not the case for the first flight, but it is a target that is completely at reach for the next flights. And this has allowed not to climatize completely this huge cathedral that is the mobile gantry. And the other point that is extremely important is treatment of waters, because we use a lot of water during the chronology for different purposes. This water cannot be re-injected in the nature before to be treated, because it's plenty of pollutants, and those two elements are something about which we shall be quite proud. Coming back to the first flight was not only for the purpose of the qualification of Ariane 6, the inaugural flight, put into space real payloads. Of course, there are payloads with modest dimension, masses and sizes. They were assembled on the top of a structure that is there for qualification purposes. So that has a mass and a kind of moment of inertia that was precisely defined in order to match certain flight condition, a certain important flight event, notably during the ballistic phase into orbit after the separation of the payloads. We have served a number of university, research centers, also industry that wanted to make some in-orbit demonstration of their products. And this is a classical approach of ESA to offer inaugural flights, offering a launch possibility to people that otherwise could struggle in finding a cheap, low-price launch opportunity. Again, we did it, and we are very proud also about this.
I think we should.
And then, finally, the launch day. The launch day, if I don't mistake, we have a movie that can speak better than words. Yeah. This is what has happened on the 9th of July. I think that images speak better than anything else. The onboard cameras. Many of you have already watched the movie, the video live. It was retransmitted on the online platforms.
Pilotage calme, trajectoire nominale. Séparation des ESR. Séparation de la coiffe. Séparation LLPM. Allumage du moteur Vinci.
The mission, what we call the commercial phase of the mission. Was completed with the payload separation and injection to orbit. I will not read every figure, but the environmental level that we have measured in flight are very, very, very much comfortable and satisfactory for us. The propulsion curves, the propulsion data were perfectly fitting the previsions. And the separation phases, the transient phases of the flight, the maximum dynamic pressure, separation, etc., were always exactly fitting the forecast and well inside the safe margins of qualifications. The most important factor, but this I would like François to explain the importance of the reignition of the Vinci.
It was very important to demonstrate that we have this capability. So we have tested this a lot on ground, but you know that on ground it's a bit difficult to simulate microgravity, especially when you want to ignite an engine. And so we knew that it was theoretically possible. Everything was put under control, but this is only in flight and in orbit that you can test. As I said before, not only that the engine itself is reignitable, but that the stage is able to perform all the maneuvers so that you can prepare the propellant and the feeding system to be exactly as it is needed to reignite an engine. And this was the challenge of this first test, first flight. And of course, we were very happy to see the Vinci running a second time during the maiden flight. And at the end, we were also very happy to see that we have on Ariane 6 an accuracy which is comparable to Ariane 5, even a bit better. But that means that what was the beauty of Ariane 5, you know that, for instance, on the James Webb Telescope, we put the telescope into a very perfect orbit, that we have the same capability, the same features on Ariane 6, and that we can guarantee to our customer that we will put their satellites, their missions into the right orbit with a very good accuracy.
Everybody knows that this means having maximized the lifetime of the spacecraft that is released to orbit. In the little movie in the center, we see something captured by the camera installed on board a spacecraft that has been developed by the ESA League of Junior Professionals. And this is another very nice fact to record. And then, Olivier, I leave you.
So no, very quickly, because I think time is running, we will not have so much time for question and answer, but I think you can understand that for me, for us, for all the teams, this 9th of July was really a major achievement, really intense. To say about me, I was sincerely confident on the success of the Ariane 6 flight until 30 minutes before the H0. And then I begin to think about what if and so on, and have we made all the maximum and so on. And then after liftoff, we had step by step all the success of the flight, and it was really a great achievement for everybody in Kourou, everybody in Europe, in mainland Europe, as you can see on all these pictures.
And so, of course, the inaugural flight was a huge challenge in the development, but this is definitely not the end of the story. This is just the beginning, and what we have in front of us is to serve our customers. And so we have 30 missions in the backlog of Ariane Espace. By the way, I'm presenting this on behalf of Ariane Espace because Caroline Arnaud, who is the Ariane director, cannot be with us today. And so now what we have in front of us, this is the second challenge, which is to enter into the exploitation of this launcher for probably many decades, with some improvement along this part of the history of Ariane 6. But the ramp-up is a challenge, sometimes more difficult to achieve compared to the development and the inaugural flight. Should not do so, say that as a program manager for the development, but this is true. The ramp-up is very, very important on Ariane 6. We have many customers waiting for us. Next year we intend to fly 5 times. So 1 the first year, 5 the second year. This is quite a ramp-up, and the year after we intend to have 8 to 10 launches a year. So very rapidly we have to ramp up. As I said before, this is not magic. This is because we have the production facility, we have the storage capacity also in Kourou, and this is not just producing the launcher, this is also launching the launcher, so the launch base capacity is also very important. And for that, as I said before, very soon in the process we have developed new factories with new production tools and processes so that we can launch 2 times more than Ariane 5, and we can very rapidly ramping up. I think this is the and this is what I said before. We have an order book, 30 missions, 2/3 for the commercial, because you know we have this contract with Kuiper, 1/3 for the institutional, but we continue to have very good discussions with a lot of future customers. And so after this inaugural flight, which was a success, and you can imagine how much it was important to have this success, we are now in this exploitation of Ariane 6 with a very brilliant future, because the customers, they are there, they want to fly on Ariane 6. We provide them a very reliable and high quality service. And this is also something which is very, very important in our business. So long life to Ariane 6. And just a word before we start thinking about the evolutions of Ariane 6, so that we can provide more performance. We can increase the flexibility of the missions. So here again, in terms of definition, this is not the end. We will continue to increment the definition of the launcher so that we can progressively serve our customers, institutional and commercial, with better performance, more flexibility for their missions. And this time it's it.
Thank you very much for this trip through the main step of the inaugural flight and the success. I have a few questions from the audience that I have collected here, so I will try to relay this to you. So we have around 5 minutes to discuss this topic. So first question is for François. You were talking about lessons learned and the secondary propulsion system that has been used and for reignition of the upper stage during the inaugural flight. After the successful second reboost, we also had a lessons learned about an anomaly on this, and the people would like to know how it has been treated. Is there an impact for the second next flight? And do you see something that prevents from giving the successful flight as we mentioned today?
Yes, thank you, Aline, for the question, and thank you for the people who asked this question. Yes, it's very important to explain that during this maiden flight, inaugural flight, we had two very different sequences. The first one is I would say, the Ariane standard. We go into orbit, we demonstrate the capability, we release the payload, and when we launch, we need to make sure that we have understood the complete design of the launcher is capable of doing that we have qualified this, that we have made all the tests for this and the computation for that. So this was the first sequence.
To be clear, with reignition of the upper stage.
With the reignition of the Vinci, we had two boosts of the Vinci, and so the reignition of the Vinci was part of this Ariane standard. We need to demonstrate it works, and it worked. And it was a full success, as said and presented by Pierrot. All the sequence, everything which is at risk, especially on a maiden flight, it was absolutely perfect on Ariane 6. And after, we had this second phase of the inaugural flight, and it was dedicated to test in flight what we cannot test on ground. So it was like a test in flight compared to the test that we have on ground, because as I said before, the behavior of the fluid, the thermodynamic joined to this with the fluid, and the effect of the macro-G and so on. This is something you cannot test on ground. So you test on ground with gravity and thermodynamic conditions, and after you translate with your computation to what could occur in flight. But of course, what you put in your model is what you know. what we wanted to test is what we don't know. And of course, and this second part was dedicated to this. And so we have made the second part of the flight, which was very risky. We tested the systems to the limit to have as much as possible data. And yes, we had an issue with an anomaly with the reignition of the APU. Not because of the APU, but because of the thermodynamic conditions. We have put so many measurements on the launcher, including cameras and so on, that we have clearly identified the reason why this system was not able to reignite. And by the way, we reignited, but we had the control that makes the software, okay, I'm not sure it will work perfectly, so I don't want to have a debris into orbit, so I stop the engine. By the way, we could have continued and so on, but this is a second story. And so we have understood this very, very well because we had the data. We have corrected the sequence, especially a correction of the software. And so for the next flight, everything now is under control for the first commercial flight. And in addition to this, for an inaugural flight, you can imagine that we go through a gigabit of data to look at if everything is as expected, and sometimes this is within the limits, but you would like to understand why this is not exactly what you have predicted. You go through, you look at it very carefully, you adapt your model, you look at it, and this is where we are. But everything which is needed to fly a second time is now totally understood and under control. And we are preparing this with the next customer, explaining this, okay, this is the first flight, this is what we have modified, and this is why we believe we can fly with you.
Thank you, François. Olivier, can you just add some information about how the people managed to operate the ground software at CNES and then relay all this knowledge to the Ariane Group team for the first launch, how it worked?
Yes. So, as mentioned before, the ground software and the ground control and command system was developed by CNES, but from the beginning of the development, it was performed, the control bench and the associated ground software was developed in a common team with people from under leadership of CNES, but with people from Ariane Group integrated in the team. Integrated in a team, not only to answer to your question, to prefigure this transfer of exploitation, but also to be sure, because it's something that is really integrated, the need of the launcher, this control and command system need to answer to the need of the launcher. So it has been, and there are also, on the other side, if we have some specificities of the ground control and command, there may be an impact on the launcher. And these integrated teams, one for the control bench and one for the software on the ground software, was a common team, Ariane Group CNES from the beginning. Then the other part of the answer is how I presented the progressive implication of Ariane Group in the command test in the first campaign, and then now in the second campaign. And by the way, in the second campaign, we will still CNES be present. Less present, but still be present to help, if needed, Ariane Group to take these activities.
Thank you, Olivier. It's very major, critical steps to be sure that we have these softwares like very major for the next launch. And just to finish with you, Piero, could you tell us a little bit more about the next developments and technology that will be used for reusability of the launcher?
Reusability is, of course, a sort of mantra. Everybody wants launches that are reusable, and I think we have fully understood that to the point that ESA started since quite some time developments in the technological and the preparation of future. with project like Prometheus, Themis, and also some other that looks rather than the smaller size of launchers in the Vega world, to introduce us very soon reusable stages in the architecture. We don't know if it will still be called Ariane 6, but this is not the point. But from a technological standpoint, we can say that ESA doesn't miss any activity and competence to go to the reusability. Now we have to decide the smartest ways to introduce that and to develop all the infrastructure that goes with reusability, because the life doesn't end with the landing of a stage on a barge or on a launch pad. We need to implement all the infrastructure for the refurbishment of the stage and preparation for the next time. And this is quite an heavy task that we have to introduce smartly and carefully.
So we are working on it, and it will be introduced in the next technology pillars of the launcher's development. Thank you very much, sirs. I would like to thank the audience for being there today, and join the end of the ISC, and happy Friday. Thank you very much.